In the previous video, we learned the basics of information visualization, the human perception, and also the Gestalt psychology. In this video, we'll learn about how to apply all these principles to design effective charts. You may recall from previous videos that we talked about pre-attentive processing and also the Gestalt laws. And we say that pre-attentive processing allows it to detect things very quickly. But detecting quickly doesn't really mean that we can detect things really accurately, which means if we can say something happened, it doesn't really necessarily say that we can figure out exactly how much something has changed. And ideally, you want both. There has been research to look into this. Specifically, there was a study in 2010 by Professor Jeff Hare and his students to look at how the different kinds of charts would allow people to detect things quickly and accurately. They look at different kinds of charts, such as bar charts in T1, T3, and also charts that uses area, such as circular area in T7 and tree map in T9. And what they found was that for charts that uses position, such as in T1, like in bar chart, where the changes are encoded by length, people can very quickly and accurately say what the changes are. While as you go down further, for charts that uses area, like pie chart, circular area, tree map in T9, for example, then people are not really good at doing so. Actually, for circular area, that's particularly problematic, because if you say you show people two circles and say which one is bigger, which one encodes a bigger number, and often they can just tell you which one's bigger, but they cannot exactly tell you by how much, because there's an ambiguity in interpretation. So one way to interpret it could be actually by area, which we will do some math to compute it. And other is to say, well, we can compare them using their radii or their parameters. And both of them are not really easy to compare. And for that reason, these charts can be really inaccurate. And you see that actually circular area is the most problematic here. In summary, what that means is for positioning or using length, those are really accurate. And you can also detect them very quickly. And as you go down, where let's say we leverage this angle or slope of the items that we're looking at, then we get worse. And the even worse are the cases that we use area or volume. And for the very interesting case is that color is actually the least accurate. So you may notice that when we talk about pre-attentive processing, we say color or hue, we can detect it very quickly. And while we can detect them quickly, we're actually really bad at saying by exactly how much that, let's say, two shades of red are different. So this means that you ideally want to combine both the visual encoding, like positioning and length, and also more subtle design decision, like saying color more effectively, so that our design would be most accurate and can be detected quickly. So what does all this tell us? It tells us that bar charts, scatter plots, and line charts are all really effective for visualization. And because they combine all the best, or the most accurate, and also the most easy to detect. For example, in bar chart, we use this length. In scatter plot, we use a position. And for line chart, we use a little bit of slope and also position. And in general, for statistics distribution, besides using line chart, bar chart, and scatter plot, one very good tool is the Tukey Box Plot. You've probably seen this already. If you haven't, here's a very quick overview. You'll see some rectangular box here and also maybe some lines and dots. And what this very compact visualization encode is the median in the middle and also the quartile, first quartile on the lower part of the rectangle, and the third quartile at the upper part of the rectangle. And also there are some points here which are showing the outliers, things that are not really falling into the expected range. So what we saw previously was to say that, well, there are three kinds of charts that are really effective. But how do we design them? We can follow Tukey's chart principles. So this is probably the second time, and you'll see him a lot more second time that we see ever Tukey. So what are the principles? So the very first one is what we call do not lie. And the second is to maximize data to ink ratio. And the third is to minimize chart junk. So we'll start with the very first one, do not lie. What does that mean? Why would we ever lie with data visualization? So here's a very good example. So you probably remember the oil spill incident a few years back. And there was, of course, an oil collection effort. And in one of the presentations, we saw a chart like this, where the company representatives say, we are doing a very good job at collecting oil, and you see that our collection is actually ramping up. So if you look really closely to the title of the chart, you will see that this is actually a chart representing the cumulative oil collected over the dates. So what does that mean? If we're looking at cumulative, that means the sum is always going to increase. And the worst case is just stay the same. So on the right here, we're showing the oil collected daily. So that means no longer cumulative. And you will see that actually that's not really ramping up anymore. We're actually slowing down. So there's a ramp up in the beginning. But then once it reach the peak, then it could slow down. And then in the later days, it actually stall and it stay at the same rate. So that is an example of what Tukey would say, do not lie. So that means we should be truthful. We should be trying to pick the chart that would tell the best picture as possible. And the second and the third principle, maximize data to ink ratio and minimize chart junk, often get discussed together. The second one means we want to span all the ink that we use, let's say when we print a chart out, to be dedicated to the data. So that means every single drop of ink, ideally, it should be representing data instead of representing some kind of decoration. So by maximizing this data to ink ratio, that means we're really showing people everything, all the essential things that they should care about. And naturally, that would also help us minimize chart junk, because chart junk means decoration or things that are dormant that are not really critical in helping people understand data. So by maximizing data to ink ratio, naturally, we will also reduce chart junk. So here's a very good example to show you what we mean. On the left, we see a bar chart here. So the data that we really care about actually is encoded completely in the length of the chart. And while the green background, for example, there's some brick, if you can see them clearly, and also a lot of horizontal lines, for example, they're actually including or even making the labels, let's say the axes, on the vertical axis or the horizontal axis, really hard to read. So it has a really low data to ink ratio, and also there's a lot of chart junk. And similarly, on the right, we have a map. And here you can also see that the gradients behind each of the countries actually also not necessary, because all we care about is the boundary and also the name of the country. And all those gradients, although they might be interesting to look at, they're not really informative. And finally, I would say, please, 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 no pie charts, or no 2.5D charts. So pie chart is actually really popular. You've probably seen a lot of these in business presentation. But I would argue that they are really not good visualization. So let's say we look at this example. And I would even give you a hint. I would say, well, there are 3 big pieces of pie here. And 2 of them, actually all 3 of them are different. And the 2 biggest pieces, the dark gray and the lighter gray, they actually slightly different. So which one is bigger? Probably pretty hard to figure out. So the darker one is actually bigger. It's a value of 37. And the smaller one is 36, off by only 1. So here you see that pie chart is not really good at helping people to distinguish between these small differences. And this is what we call 2.5D chart. So this is really, really bad. The main reason is because it's unclear what the length here is really encoding. We have like volumes of pillars. And if you look at the vertical axis, you will see that it starts from 0 to 40. So what can we say about the first bar? How tall is it really is? But notice that the vertical axis is not really starting at whether it's the front or the middle of the column. Instead, it's like a little bit offset, more coming to the front of the screen. So what that means is we don't really know where to start the measuring and where to end the measuring. And this is even worse. So we not only have pie chart, we also have it in 2.5D. So please, please, please don't ever do this. Not really good. And if you really want people to be able to detect things accurately and very quickly, you can just use a bar chart. Even though you might say this is very boring, but it's extremely effective. And here, same data you saw previously using pie chart and 2.5D bar chart. Here, you can very easily see that one is slightly longer than the other one. What we just looked at are some basics of chart design. and we look at what to do, what not to do, and we saw that scatter plot, bar chart, and line charts are really effective, while for something like a pie chart or 2.5D chart, we should rarely do them.